this video, we are going to solve absolute value inequalities. So from part B, you remember that our simple inequalities, like the absolute value of x is greater than or less than something, gave us a solution set that was an interval. Okay, also, sometimes the solution did not exist. To solve an inequality, you work the same way as with equations, except if you multiply or divide by a negative, you must reverse the inequality symbol. So graphically, let's see, when does the absolute value of 2x minus 4, when is it greater than or equal to 2? Well, it's equal to 2 at not minus 1, but 1 and 3. And then it is greater than those values up till 1 and after 3. So the intervals are from negative infinity to negative 1 and 3 till infinity. We're using square brackets because it can be equal to those values. The second one, when is this absolute value of the negative absolute value of x plus 1 minus 2? When is it less than or equal to minus 1? Well, always. This function, because it's been flipped and translated down, is always less than negative 1. So algebraically, let's think, when is the absolute value of x plus 8 less than or equal to negative 2? This has no solution. It is impossible. This absolute value will make a positive output. No positive number is less than or equal to negative 2. Over here, we have the absolute value of 2x minus 5, so that's going to be a positive output. When will that be greater than or equal to negative 2? Well, always. It'll be all real numbers will give this an answer that is greater than negative 2. When is the absolute value of 3x plus 1 greater than 7? Well, this is going to be sometimes. It'll be something like this. There'll be a couple intervals where this is positive. So note, there are some things that are never, some solutions that are always, and some solutions that are sometimes. So to work out the sometimes, we'll have to use our two cases, as we said, just like what we did with equations. So either we have the positive input, so 3x plus 1 is greater than or equal to 0, meaning that the input and the output are the same. So if the input is positive, the output is 3x plus 1, and that inequality will be greater than or equal to 7. So 3x will be greater than equal to 6, and x will be greater than or equal to 2. This I wasn't dividing or multiplying by any negative, so I just solved it as if it were an equal sign. So now what about the negative input? That is when 3x plus 1 is less than 0, and the absolute value will produce an opposite value. So it'll be the negative of 3x plus 1 greater than or equal to 7. So negative 3x minus 1 greater than or equal to 7. Going to move the 1 over. And now I'm going to divide by negative 3. So I have to switch my sign. And now x is less than or equal to 8/3. So what this means on a number line, so less than or equal to negative 8/3 or greater than or equal to 2. Okay, and then that can help you use your interval notation. So from negative infinity to negative 8/3 and from 2 on. And you can always check a number in the interval, so say 3. So the absolute value of 3 times 3 plus 1, so that's 10. 10 is greater than 7, yes. A number in this interval would be like minus 5. So 3 times minus 5, so negative 15 plus 1 is negative 14. The absolute value of that is 14, and that is greater than 7. Good. So you can just do like a check in your head. These intervals are correct. Over here, we still have to remember to isolate first. 2x minus 8, the absolute value is less than 24 minus 9, so 15. Okay, our input is positive if 2x minus 8 is greater than or equal to 0, and our input is negative if 2x minus 8 is less than 0. If it's positive, our input is equal to our output. If negative, our input is the opposite of our output. I will solve this by adding 8 to 15 and then dividing by 2. I think I put one negative too many there, so I'm going to multiply out that negative, distribute it, negative 2x plus 8, negative 2x, and 15 minus 8 is 7. And then I'm going to divide by a negative number, so now the sign switches to x being greater than negative 7 over 2. So now let's check. I've got all the x's less than 23 over 2, but greater than negative 7 over 2. So this whole interval, so I have all the x's in between negative 7 over 2 and 23 over 2. All right, so check out the bonus. There will be 4 cases. So either they're both positive, they're both negative, or the first is positive and the second is negative, or the first is negative and the second is positive. So you'll have to make 4 different cases. You can also check and see if some of those cases contradict each other, and then you won't have to check it. But this type of question is more work than some of the ones that we did, so could be fun to give it a try.